Okay, the next problem gives us this cubic right here, inequality, and we need to solve, or I'm sorry, solve this. So what I'm going to do is I'm going to put everything on the left side. So I'm going to subtract 4 from both sides. And then I'm going to group. I don't know if you remember factor by grouping, but I'm going to group together the first two terms and pull out an x squared. That leaves me with x plus 4 quantity. And then I'm going to factor out a -1 from these two terms, and that leaves me with x plus 4 again. So the nice thing about factor by grouping is now I can pull out this number right here, which is x plus 4. It's just a number, and I can pull it out of both terms. And then I'm left over with x squared minus 1. So now when I go to make my sign chart, I put the key points on there, which is obviously -4. And then also -1 would give us a 0 here, and so would +1. So I put -1 and +1 on there. Now I test these regions, so stick in -5. -5 gives you a negative here and a positive there. So overall that would be a negative. And then pick a number between -4 and -1, like -2. Gives me a positive there and a positive here. So that would be positive. Now pick a number between -1 and 1, like 0. 0 gives me a positive here and a negative here, so that'd be a negative. And pick a number greater than 1, like 2, gives me a positive and a positive, so that would be back to positive. Now what I want to know is when this thing's greater than or equal to 0, so I'm going to include the zeros. These points are going to be included because they're all zeros. And I want then where this is positive, where it's greater than or equal to 0. So I want this region and I want this region. So in interval notation, that's -4 to -1, including both, because those are included. Those zeros are included because that's equal to. And I also want anything bigger than 1, including 1. So there's my interval notation that describes the solution to this inequality. Now I know we're not supposed to use the calculator, but let me check this in the calculator. If I plug the function in, I plug this function in right here. I want to find out where it's positive, where it's greater than or equal to 0. If you look, we got our answer from -4 to -1. It is positive there. And from 1 to infinity, it's positive. So our answer checks out here. All right, the next problem wants us to factor completely. This is a sum of 2 cubes. Now, if you just, I didn't put this on the formula sheet. I don't even think we talked about this here, but if you just Google difference or sum of 2 cubes, the formula is one of these factors and one of these. And it says the minus sign goes, for the sum of cubes, the minus sign goes in the quadratic factor right here. So that would be, it'd be this formula right here. A cubed plus B cubed equals A plus B is the linear factor, and then A squared minus AB plus B squared. All right, here we go. I just Googled sum of 2 cubes, so it's right here. So what A is X, and then what B is, this is really 2 cubed, so B is 2. So A is X and B is 2. So we can just go ahead and fill this formula out then. It's X plus 2 times quantity X squared minus 2X plus 4. If you just plug in, X for A and 2 for B. And there we go. This is an irreducible quadratic, by the way. You're not going to be able to factor this at all, so you can just leave it just like it is. Okay, the next topic is derivatives and parametric equations. So let's do the derivative of this. It wants us to do the definition of derivative, which is what this is, and just fill it out and simplify. So we don't have to take the limit as h approaches 0, which is to finish it, but we do have to do the algebra part. And to do that, it's f of x plus h, which would be 2 times x plus h plus 3 minus the function, which the function's right here, 2x plus 3, all over h. And I can simplify this a little bit, so let me distribute here the 2. This gives me 2x plus 2h plus 3. I'll distribute the negative sign. It'll be minus 2x minus 3 all over h. And these are going to cancel, the 2x and the negative 2x, the 3 and the negative 3, and I just end up with 2h over h, in which case the h's cancel and I just get 2. So I don't even have to take the limit because the limit as h approaches 0 of this function is just 2, which we know because we know the power rule, which is that you multiply the exponent down right here to get the derivative, which is just 2. All right, so just one more real quick. When we take the derivative of this, we get 2x plus 3. So let's just do it with the algebra. The algebra is f of x plus h minus f of x all over h. So let's go ahead and fill this out. Plug x plus h in for x, and you get x plus h squared plus 3 times x plus h. Then we need to subtract the original function, x squared plus 3x, and that's still all over h. So I'm going to simplify. Let's FOIL out the first, and I get x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x. So I just distributed this and this as well. All right, so let me simplify. This x squared cancels with this negative x squared. This 3x cancels with this negative 3x. And I end up with, I'm going to put this as h squared plus 2xh plus 3h all over h. Now I can factor an h out from the numerator, and I get 2x plus 3. And that way the h's cancel, and I get my answer, which is 2x plus 3. Okay, next one is a parametric equation. It wants us to write this as basically a function of x and y, so it wants us to eliminate the parameter. So what we can do is solve one of these for t. Like the top one, for example, becomes t equals x minus 1, and then I can just plug this in for t. So I get y equals x minus 1 squared minus t, which is x minus 1. So if I simplify this, x squared minus 2x plus 1, and then distribute this, I get minus x plus 1. And I can simplify this a little bit more. It's x squared minus 3x plus 2 then from my function. So if I were to graph this in parametric mode, these parametric equations here, I should get this parabola right there. Okay, next is function transformation. So let's let a function f of x be x squared minus 1. So we know that's a parabola that is shifted down 1 unit. So it looks like this. Now, describe in words what would happen if we did this to the function. So if we subtracted 4 from the function, well, that would move it down 4 units. So we could just say down 4 units, shifted down 4 units. You know, you could actually do it. So here's f of x squared minus 1, and if you subtract 4, you get x squared minus 5, which is going to go through negative 5 down here, shifted down 4 units from the original. So you would just say down 4 units. Okay, the next problem wants to take the original function and add 2 to x, and also change the value, the sign on the y value, change the sign on the function. So that would be f of x equals x plus 2 quantity squared. We'd have to change the sign. This is a reflection over the x-axis. And this one is a shift, a horizontal shift. And that would be 2 units left. If you add a number to x, it was to the left, kind of the opposite of what you think. So there's what we would be doing to this function. And you can graph it and see that if you graph this in the calculator, you're going to see that one is, here, and the other one is reflected and then shifted over. So it would be here. And in fact, I need to follow that negative sign through. I'm sorry, I have to change this value on everything. So this would be a positive now. So it's reflected. You do the reflection first and then the shift. So if you graph, this function right here and this one, you should see these two. The original, and then one that's reflected over the x-axis and then shifted to the left. Okay, the next then is topic 10, which is the factor theorem. P over Q, and then we're going to do synthetic division. So we want to solve this. We want to factor this completely. So what we're going to do is take factors of the last coefficient, which would be P, over factors of the leading coefficient. So we have plus or minus 6 over 1. We have plus or minus 3 over 1. And we have plus or minus 2 over 1. And plus or minus 1 over 1. So all I did was take factors of the last coefficient, which are obviously 6, 3, 2, and 1, over factors of the leading coefficient, which is just 1. And you have to do both positive and negative. So basically we have plus or minus 6, we have plus or minus 3, we have plus or minus 2, and plus or minus 1. Those are the places that we have to check to find out which ones are zeros. Now, I know this takes a while because there's 8 of them that we have to check, so I'm going to use the calculator to just graph this real quick. And I find that -3, -2, and +1. -3, -2, and +1. Those are the places that would have worked had I plugged all these in. And so then obviously this factors into x plus 3, x plus 2, and x minus 1. Okay, let's try one more of these then. This one, the factors would be the same because we have the same coefficients. So we have plus or minus 6, we have plus or minus 3, we have plus or minus 2, and plus or minus 1 to check. Now, if we graph this thing, what we find is that -3 is 1. The other ones are at rational numbers here. We can tell they're fractions, and I'm not sure what they are. So let's take the -3 one. So that'd be x plus 3 is one of the factors. And let's divide that into the polynomial. Now, since -3 is the 0, I'm going to divide in -3 synthetically. 1, 1, -8, -6. So you can do long division if you want, but I'm going to do synthetic. You drop down the 1, and you multiply. You add, and then you multiply. Then you add, and then you multiply, and we get no remainder, which is good. So what that means is, with this factor x plus 3, the other factor is right here, which is this irreducible quadratic right there. So we know that this polynomial right here factors into this one right here. And we know also that this is an irreducible quadratic. So we're just about done. Here's p of x. But it's factored completely. It's just that they want us to solve it for when it's equal to 0, which I actually forgot to do for the last one. But the zeros, obviously, for the last one were, 3, 2, and 1 or whatever. 3, 2, and -1. But this one, obviously -3 is one of them. So the zeros are x equals -3. But there's 2 more that come from right here, and they're irrational. To get those, we're going to use the quadratic formula. So we're going to do the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, and we can simplify this. Double negatives go positive, so we get 8 plus 4 is 12, and this is 2 in the bottom. Now I'm going to break 12 up into 4 times 3, in which case the square root of 4 is 2, so this turns into 2 plus or minus 2 square root of 3 all over 2. Now the 2's cancel, and I get 1 plus or minus the square root of 3. So there's my 2 other zeros. So I'm going to write those right here. I'm going to write 1 plus the square root of 3, and also 1 minus the square root of 3. So there's all 3 zeros. These ones were a little bit hard to find because they're irrational. So on the calculator, 1 plus the square root of 3 is obviously this one right here, almost 3, and 1 minus the square root of 3 should be, almost -1. But these are your zeros right here, and you're all set. Okay, the next problem wants us to determine whether we have an even or odd function. Now, on the formula sheet that I gave my students for odd functions, you get this. So odd functions, you get this. Then for an even, if you stick in -x into the function, you just get the regular function back. All right, and that comes from the fact that an even function is symmetric about the y-axis. So this is x, this is f of x, for x and y. And then if you plug in -x, you get the same y value back out. So that explains this. Explains why when you plug in -x, you get the same y value. And then for an odd function, it's similar in regard to, they look like this, where they're rotationally symmetric by 180 degrees. So if this is x and f of x, then when you plug in -x, you get the same y value distance, but just on the other side. So it'd be, negative f of x. Be, down that y value instead of up that y value. So that's where these come from. And we can use those to test algebraically whether these are even or odd, and that's what we're going to do because it says show work to determine. Now we can graph these and get an idea as well, but without a calculator, it says we can use the calculator here, but we don't need to. We can determine by just plugging in -x what happens here. So f of -x for this would give us 2 times -x squared minus 7. Let's simplify this. This turns into 2x squared minus 7, which is the original function that we had back. So this means it's even, because this is the original function f of x. So we just showed algebraically this right here, that when we plugged in -x, we got f of x back. So it must be an even function. And it is, because we know it's stretched and it's shifted down 7 units. So, it looks like this, which it's a horrible drawing, but you get the idea. It's still symmetric about the y-axis. It is even.